Hello everyone, my name is Semyon. I'm a software engineer at GridGain Systems, and a little disclaimer here. I'm a part of the core team, primarily focused on persistence and communication. But I'm a big fan of the open source and Spring framework, and I also tend to contribute a lot to Spring framework. So today I'll be talking about how to build a reliable web application using Apache Ignite and Spring framework. What we are building here is a simple game of a hangman. The game where you create a word and the user must guess the word. If the user guesses incorrectly more than several times, he loses. If the user guessed the word, yeah, he won. So let's start. I have a little hint. I won't be doing live coding because while live coding, I tend to do silly mistakes. So I've written all the code beforehand, and I'll be just checking my comments. So yeah, let's start. What we have here is a simple Spring Web initializer project with only one class. Yeah, it's a simple Spring Boot application and a POM XML, which I have modified a little bit. So let's see what we have here. Yeah, we have Spring Boot starter security, so we can authorize our users and Spring Boot starter web. Yeah, we also have Spring Session and Spring WebSockets, but we don't really need them. Now we also have Ignite Spring Data and Ignite Spring Boot after configure. We will need these two models so we can use Ignite and Spring Data both simultaneously. And also Spring Boot after configure is a good tool, so you'll practically have zero configuration. Yeah. Let's start our application and see if it works. Yeah, as we can see in the logs, the Spring part is started successfully, and also the Ignite node is also started up fine. Yeah, what about the front-end part? I've written a simple front-end using React.js. By now you can only see the login page because, well, we don't actually have any logic on backend, so we can't even log in. Yeah, all the front end is already written. I won't be showing much of the front end because, well, it's not about front end, it's about backend. So yeah, we'll see the front end later. Now let's move to the next part. Let's look at the configuration part. Yeah, so we will need to configure our Ignite model. We'll have to enable Ignite repositories so we can use Spring Data and Ignite. Why do we need Spring Data in the first place? Well, if you use just simple Ignite, you will only have Ignite caches. And Ignite caches, it's a key value storage. But when you use SQL interface or Spring Data interface, which is basically the wrapper around the SQL interface, you can query the cache not only by the ID of the entity, but also by any field of the class that is being stored in caches. So yeah, using Spring Data is a very neat trick, and we'll be using it. Also, there's a little workaround. Currently, Ignite after configuration creates a Spring bean for Ignite, which is named Ignite. But Spring Data integration requires an Ignite instance, Ignite bean, which is called Ignite instance. So what we do here, we just inject Ignite and return Ignite instance bean. Yeah, it's practically the same bean, just with a different name, so that Ignite Spring Data model will be happy. Yeah. Yeah, I've also created three classes for our business logics. Yeah, it's a class of the game and a class of the user. Also, game state is just a simple enumeration, so we can track the state of the game. Let's look closely at how we build our domain classes. Well, it's practically a simple poja with ID. You always need an ID. It can be, well, any serializable. I decided to go with UUID. And yeah, just some simple fields. But notice the annotation here, the query SQL field. This annotation is required for Spring Data integrations or SQL API integrations. If you want to use this field in your query, for example, if you want to select all the users by username, you have to annotate this field with query SQL field. Yeah, and if you pass through to the index argument of this annotation, you will have this field in the index of the SQL table. Yeah, here in the game we have practically the same. Yeah, I've annotated the state because I will be querying by state, user because I'll be querying by user, and yeah, of course the ID field. And yeah, let's check if everything still works. Yeah, it seems like it works. We have our Ignite instance and it works. Let's move to the next step. So what do we do next? We want to authorize our users. We want to store them in the Ignite caches. Yeah, we will have to provide some configurations for Spring security, and we will be finally able to log into our web application. So the first thing is to update our Ignite config. You can create Ignite configure bin, which will be used by Ignite after configuration model. Here you can return the Lambda or some anonymous class where you can register the caches. For now, we only register the cache for the users. Notice that we have to pass the name for the caches. And also we must provide the types of the cache. So the ID of the cache and the object stored in cache itself. And also we pass this configuration into the configuration of Ignite. The next thing that we do, we create the Spring Data repository. It's practically the same as creating a JPA repository or Mongo repository or something else, because we annotate this class with repository annotation, but we also have to add a repository config annotation. and provide the name of the cache. Also, we derive our interface. We extend the Ignite repository class, and provide practically the same things that we passed in the cache configuration. So the ID class and the class that's stored in the cache. I've also written a simple method, find by username. Actually, in Spring Data repositories for Ignite, you can use all the things that you can normally use in any Spring Data model. So like you can write find something by something. Yeah, it works. Even IntelliJ helps me writing these methods. What we do next? We'll write security configuration and the REST controller for authentication. Let's look at the security config. Yeah, security config, it looks kind of big and scary, but we won't be needing all of these. I'll just show you the good parts of it. Yeah, what we do here. For those of you who are unfamiliar with Spring Security, Spring Security is a cool tool for creating authorizations, authorization processes very easily with practically much less code than you do it by hand without Spring Security. So what we do here, we allow every user access the URL that starts with auth, and any other request should be authenticated. So users who are not authenticated, anonymous users, when they can't access all the other URLs. We also enable HTTP basic authentication. We disable CORS, CSRF, because we don't really need here CSRF because what we have to secure here. And we enable CORS, cross-origin requests, because we will be making requests from different host and different port. Because I do run my front-end model on the port 3000, and my Spring application works on ports 8080. Yeah, here is some course configuration that allows calling our API from any host. Yeah, it's not really interesting. Here's some boilerplate code for Spring Security. Yeah, and the interesting part, we are creating a simple user here on the start of our application. It's just a user with a simple username and a simple password. But you should have a look at the method save, because there's a little trick here. Every time you save your entity to the Ignite repository, you should call save method with not only the entity itself, but also with its ID. Yeah, it's mandatory. What do we do next? Yeah, we also need to provide user detail service. It's a thing used by Spring Security to locate users in any any storage that is back in the security service. So you can store your users in a hash map or in a file. It doesn't really matter when you provide the detail service. I've written some very simple detail service. It just takes our user repository, it injects it, and calls the method find by username. So if there's no user, we throw an exception. If there's a user, we return our simple wrapper object. This wrapper object naturally consists of only our user object, or this user. And it overrides all the required method that tells Spring Security that this user is active, the account is non-logged, non-expired, and enabled. Yeah. It also has a method for granted authorities, but we don't really have any authorities or roles in our application, so we just return an empty list. And the last thing in the authorization part is our F controller. So this controller can be accessed by any user, both anonymous and authorized. What we do here, we just take the username and the password provided by the user and manually authorize it. So we call the auth managers method authenticate and store the result in the security context. And when we update our HTTP session, by the way, the best way to update the session when you authorize user is to always call request get session true, because this way we will create a new session and we will avoid the session pinning exploit. And so, yeah, this is the login process. Let's check if it works. Yes, so the application has started, and let's check if it works. Yes, it actually works. But if we open the console, we will see that all the other requests fail because we only written the part where the user gets authenticated. So every other request will fail and nothing will happen. Okay, so yeah. So what we've done here, we created the authentication layer and the configuration for the user cache. Let's move to the next part. This part is the finish of our game. So this is the part where the game is playable and everything works. So what we do here, although I created some game service and game exceptions, it doesn't really matter now. Let's see at the Spring Data part. Yeah, I practically created the repository the same way I created one for user. This one is for the game class. Yeah, again, repository config annotation with the cache name as an argument. And the method to find all the games in the cache named games by user ID and the state which I provided here. I've also had to update the configuration for Ignite. So I created a new configuration for the cache called games, and I provided the classes that are ID and the game class itself. Yeah, let's go next. The game controller. Yeah, it's a simple REST controller. So we practically have a few methods here. Method to start a game, method to get the current game that the user is playing, and method to process the user guessing the word in the game. Let's briefly walk through those methods. All those methods are implemented in the game service. So in method new game, we just create a new game object. We set the word, yeah, it's hard-coded, and even the display word is hard-coded. So the word, it's the word that user will be guessing, and the display word, it's something that user will see during the process of the game. So it's just only asterisks now. But when user will be guessing the letters of the word, asterisks will be replaced with the guest letters. And here we save our newly created object in the same way that we were saving it in the security config. So we pass an ID and the object. Another method, get game by user. So yeah, we can just use our game repository and call the method called find all by user ID and state. We provide the ID and the state. This list, it's always non-null. It can be only empty, or it can contain some games. What we do here, yeah, if the game is empty, if the player, the user, don't have any games, we just return null. And if it can, it's some the user somehow playing more than one game, we will have an assertion exception, because I love failing fast. So if there's a bug in the game, yeah, I'd like to know it while developing. Yeah, and yeah, we return the first game that we have in the list, and it must be the only game. The next thing, processing of the user guessing. We do find by ID method. This method is provided by Spring Data, so we don't even have to write it in our game repository. So we don't have it here. Yeah, and we do some checks. We check that the game is in the correct state for playing, it's not finished. The correct user is trying to play this game. So yeah, the user that is trying to guess is the same user that game belongs to. We check that user didn't try to use the same character, the same letter of the alphabet to guess, and we do some replacements, and then in the end we always do game repository save, because unlike some things like Hibernate, Ignite doesn't use attached objects. So every time you get an object from Ignite cache and update this object, you have to manually save it in your repository or in your cache in SQL API. So yeah, every modification requires persisting back. Yeah, let's see how this works. Yeah, we can log in and begin a new game. Yeah, looks like it works. Let's guess. Incorrect guesses also work. And if we go back, we'll see that we have a game in progress, and we can return to the game. Yeah, so looks like our application works, and it's all right. But what is distributed or reliable about it? If we kill the node or we kill our application, the user will not be able to play the game anymore, and all the state of the game, it's only accessible on one instance of our application. So let's try making this game more resilient, and go to the next step. I've updated a little bit configuration of our application. I've created two profiles, two Spring profiles. for our game. So the first one says that server port is 8080, and the second one that server port is 8081. So we can start up two applications listening on different ports. I've also updated front-end model. I will show it here. Yeah, it does make a request to the first node for 8080. But if that request fails, yeah, for those of you who know TypeScript, yeah, we just practically catch an exception here. So if the request failed, we'll do another request for 8081. It's not the way that you would do in production, because normally in production you will have a balancer service that will check the health of your application instance, and if this node, your application node, is not responding for your pings, when you of course just don't route your users' requests to this node. But to keep it simple here, I decided that it would be easier to just make a request for the first node, and then if it fails, make a request for the second node. Yeah, let's try this. Let's start up two nodes. Yeah, so that's node 1, just active profile dev. And it's starting. And it started okay. And node 2. Okay, and it also started. Now let's restart our front-end application. Okay, let's immediately kill the node number 1 and see if it works. It will get a little laggy because the timeout of the request is like 3 or 5 seconds, so we won't get farther until the first request fails, and yeah, it's 5 seconds. But we can play the game when only a second node is enabled. Yeah, it works. Oh, it looks like I accidentally killed node number 2 instead of node number 1. Okay, it doesn't matter. Let's start node number 2 and then kill node number 1. Okay, let's kill node number 1 and check if we still have our game. Now it will get laggy because we killed the first node. Okay. Node 2 is alive. It seems like we don't have a user in our cache number 2. Yeah, the second node can't locate the user named user1. So we have to update our configuration once again. Let's kill all the nodes and update our configuration. So what happened here? Then we kill node number one that had the cache for users, we practically removed this cache and the users stored in it from our application. Sometimes this approach is okay when you only have some data on some nodes. But in this case, where we must have our users that every time the user tries to log in, the user doesn't care when that some node is active or some node is not. The user should always must always be able to log in. So we have to provide backups for our caches. Let's have two backups for this cache and for games cache. This way, the cache users and the cache games will be stored not only the node 1, but on the node 2, or the other way around. It depends really on which node was started first. So let's start nodes again. Node 1 started. Now let's get to node 2. Yeah, and node 2 also started. Let's kill node number 1 again and see if our application works. And yeah, looks like it works. It will have a little time, yeah. Okay, it works. Let's start node number 1 again. We'll be able to see if node number 1 is active because the interface will be much more responsive, much more faster, because we will not be waiting for the timeout of the request for the first node. And it looks like node number 1 started. Login. Yeah, it works. We have a game in progress that was started on node number 2. And we can continue playing our game. We can even kill node number 2 and continue playing our game. Yeah, it works. So that must be all of the demo that I wanted to show you. Now let's go over a checklist that I've created for building and distributed and reliable service with Spring Data, Spring and Ignite. It's just simple tips for starters when you just starting to build your application. Don't forget about the workaround for after configuration bin name. Yeah, it must be Ignite instance. So yeah, look at the Ignite config in the test repository. Don't forget about cache configuration. The caches are not created by Ignite itself. You must provide the configuration for the cache, and you see the benefits of it. So we can, when we have manually created the caches, we can also set the backup factor. So when the node goes offline, the other nodes won't lose the data on the node that went down. Also the repository config. So yeah, that's different from using Spring Data repositories with something like GPA, JPA, or Mongo. Yeah, we have to provide repository config, which will have a name of the cache that is backing this repository. Also the query SQL field annotation. to use the field that we've annotated in the queries. So yeah, I'll show that again. So if we want to use state here, state of the game and user ID of the game in our query, we have to annotate the fields of the game, the user ID and the state with query SQL field annotation. And if we want this field to participate in index, we have to provide parameter index equals true. And the last one, that we always persist the changes after modification. It doesn't automatically get persisted. We have to do it manually. So every time we change something, we do save it in our repository. Yeah, that would be all. Thank you for your attention.
Semyon, question from Elias is, how about using JPA with Ignite as a data repository?
JPA. Yeah, actually, JPA and Ignite, they reside on the same tier. So yeah, you can you store your data in JPA repository that is backed by some MySQL on PostgreSQL or something like that database, or you can store your data in Ignite. But you can use Ignite to provide a cache between your SQL or NoSQL database and Spring data. So either you use Spring Data with Ignite as backing database, or you use Ignite between your database, being it SQL or NoSQL, and the Spring data. I hope, yeah, I hope I've answered the question.
Elias is asking a follow-up. I assume I could define JPA at entity equivalence for Ignite caches?
You don't have to mark the class with the with an entity annotation, because Ignite does not require this annotation. You don't need it. You just create a repository and then you're good to go. You can use Ignite as your provider for storing data. So it's just a little less of code. You don't need entity annotation.
Awesome. Vishal asks, where can I get the April 7th Spring training link? Vishal, it's in the chat window. In the GoToWebinar control panel, I put it, but you can just go to gridgain.com/training. It's listed. We have actually a Ignite only training tomorrow at 10 a.m. Pacific. And we have a number of other training, but if you want to look for specifically for the spring training, that's on April 7th, and it's on the chat window here in the GoToWebinar control panel, or you can just go to gridgain.com/training. And then the next question from Vishal is, how do I set up multi-host Ignite cluster here?
It's kind of out of the scope for this presentation, but we do have a lot of discovery integrations for Apache Ignite. We have Kubernetes discovery, we have Zookeeper discovery. So if you if you want to create a truly distributed application with lots of hosts, or maybe it's in AWS or Azure, you can use like Kubernetes or Zookeeper that will provide Ignite the list of our Ignite nodes, or actually Ignite can, if you do own the little private network, or if you can create one, Ignite can use multicast communication to find other nodes. So yeah, you can actually Google search the Igniting cloud, and you'll have a link to documentation on the gridgain.com, and there will be a good explanation of how to do it. Yeah.
Thanks, Semyon. Thanks, everyone.